everybody. Today we're going to be doing our first lesson on transformations, which specifically will be focusing on translations. All right, there are 4 different types of transformations that you can have. You can have translations, you can have reflections, rotations, dilations. We'll talk about all 4 of those at some point in this unit, but today the main focus is just on translations. So when you hear the word transformation, a lot of people think of transformers, which if you thought about that immediately, awesome. You can kind of think about transformations a little bit like transformers. I'm actually going to make several transformer references throughout this lesson. First of which being, if you think of what a transformer is, transformations are kind of similar. Right? Transformers, what they do is they change from a car or a vehicle to a robot, right? They're changing what they are. Transformations are sort of like that. We're not changing to a new shape, but we are changing something about the shape. Right? So just some notes about transformations is an operation that, or transformation is an operation that maps an original figure called the pre-image onto a new figure called the image. Right? We're going from a pre-image just to an image. A transformation can change 3 things. All right, one is not the shape. A triangle is going to stay a triangle. A rectangle is going to stay a rectangle. It's never going to change shapes. But it can change the size. It can change the position. Or it can change the orientation. I think most of these are self-explanatory. Size is just how big or small it is. Position is where it's located on the graph, and orientation is how it looks. Was it rotated? Was it reflected? Does it look different than the pre-image? All right. Now, a translation, specifically, is to vertically or horizontally shift a figure or move a figure. We're going to say move. Move makes more sense here. Now, the symbolic form, which you will see it written this way sometimes, is that an ordered pair, x, y, something happens to it in order to shift it, in order to move it. What happens is that x, y becomes x plus h, comma y plus k. Got a lot of letters there, look scary, but you know what x and y are, those are just ordered pairs. H and k are just something that you use to shift or move a figure. So, for example, H just represents the horizontal shift or move. The K just represents the vertical shift slash move. Okay, so you can see in this picture, our pre-image is here A, B, C, D. I think that is a trapezoid, if I remember correctly. But this pre-image is being shifted or is being translated to the right and down. Right? Notice the orientation, the D's stay the same, the A stay the same, the C stay the same, the B stay the same. The only difference is that these now have the little apostrophes after them. Right? So these apostrophes have a name. Okay, we call them prime. Okay, A prime, B prime, C prime, D prime. That's just how we know that there was a transformation that happened. Okay, the one with the prime on it is the one that happened after the translation, after the reflection. Okay, so let's try a couple. I'm going to do 1 and 2 with you. I'll have you try some on the back. So directions, graph and label each figure and its image under the given translation, and then give the new coordinates. All right. So the first thing we need to do is we have 4 ordered pairs that we need to graph. So Q is going to be at -6, 1. So we go left 6, down 1. Label that Q. Q. Next point is -3, 1. So I'm going to go left 3, up 1. Label that R. S is at 1, -5. So go right 1, down 5. Label that S. Then T is at -2, -7. Label it T. Once you have your pre-image drawn, you can go ahead and connect the dots. Let's make our rectangle. So that's our pre-image. Our next step is that this is our rule. We're taking the x, y, and we're doing x plus 5, y plus 7. So what that means is I'm taking these ordered pairs and I'm shifting them 5 units to the right, 7 units up, because it's plus 5. If it was minus 5 to x, I would be moving to the left. If it was minus 7 to the y, I'd be moving down. Okay. All right. So let's try this. Let's take r. Okay, I'm going to go 5 units to the right, 7 units up. 1, 2, 3, 4, 5, 6. Whoop, I went too far. 1, 2, 3, 4, 5. Puts us here. Then up 7. 1, 2, 3, 4, 5, 6, 7. Puts us right here. Okay, I'm going to label that point now R prime. Do the same thing with S. 5 to the right. 1, 2, 3, 4, 5. 7 up. 1, 2, 3, 4, 5, 6, 7. It's going to be S prime. Okay, you need the primes there. It's how I distinguish between the original, or the pre-image, and my new image. Same thing with T. 1, 2, 3, 4, 5. Up 7. 1, 2, 3, 4, 5, 6, 7. T prime and Q. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, we're going to label that Q prime. And then that is our translated image. And then our last step is just to identify what our new ordered pairs are. So Q prime is now at -1, 6. R prime is now at 2, 8. S prime is at 6, 2. And T prime is at 3, 0. Awesome. So I want you to take just a minute. You can pause the video if you have to. I want you to look at our rule. Look at our original ordered pairs and our new ordered pairs. Right? Let's take Q, for example. Okay, I went from -6, -1 to -1, 6. Instead of counting right and up 7, do you see another option you could have done? Hopefully you notice that this rule was just adding 5 to my x-coordinate. -6 plus 5, -1. -3 plus 5, 2. 1 plus 5, 6. -2 plus 5, 3. And our y rule is y plus 7, so you just add 7 to the y-coordinate. -1 plus 7, 6. 1 plus 7, 8. -5 plus 7, 2. -7 plus 7, 0. Both options work totally fine. If you like going over and up according to the rule, that works. If you like just writing the ordered pairs down and then graphing, that works. What I need to see, though, is I need to see the prime image drawn, and I need to see the pre-image drawn. All right. So let's do number 2. Okay. I personally think it's faster to use the rule to add and subtract from the ordered pairs, but I'll do that this way. So for number 2, the ordered pair is 2, -1, so I go right 2, down 1. That is C. I'm going to label it at the end. D is right 7, down 4. And E is right 4, down 6. So that's my triangle. So that is C, D, and E. Whoops. E. So if you would like, you can go ahead and do your shift. It is left 3, up 6. So you count left 3 and up 6, or I'm sorry, up 8. Or the other option is we could just subtract 3 from our x-coordinate and add 8 to our y-coordinate. Let's try that this time. This is 2 minus 3 is -1. -1 plus 8 is +7. 7 minus 3 is 4. -4 plus 8 is 4. 4 minus 3 is 1. -6 plus 8 is 2. So when I graph it, I go left 1, up 7. 4, 4 is right 4, up 4. Here. And 1, 2 is right 1, up 2. This is my new triangle. This is C prime, D prime, and E prime. Awesome. So we flip to the back. I would like you guys to attempt 3, 4, 5, and 6. You can come get it checked with me when you are done. And then let's just go over number 7 real quick so you can see how 7 works, and then I'll have you guys try 8. So for number 7, it's a little backwards. This time we are trying to write the rule for the translation. All right, we got a pre-image. We have the new image. We need to find the rule. So this is where the primes are important. Okay, you got to pay attention. Am I going from this triangle to this triangle, or the bottom triangle to the top triangle? Well, if we look, the bottom triangle has the primes, so we know this is my pre-image. So our rule is always going to start with x comma y becomes x plus or minus something, y plus or minus something. So let's start with a. If this is a, how do I get to a prime? Okay, x is the horizontal shift, so I'm going right 1 unit. So I add 1 to x. Y is the vertical change, so from a to a prime, I'm going down 1, 2, 3, 4, 5, 6, 7, 8 units. So I'm going to subtract 8, and that's my rule. Hopefully this makes sense. Please finish 3, 4, 5, 6, and 8. When you're done, have it checked with me, and I'll tell you what to do next. Thanks, guys.